Hello and welcome back to the Maths Behind the Economics YouTube channel and to the Logs for Economics series. This is video 6 and this is the second episode when we're looking at some special logs. But in this video now we're going to concentrate on when logs cancel out and why, when exponents cancel out and why, and again as always I'm going to show examples. Let's get started. Let us first look at when logs cancel out the exponents. So what happens if I've got a question something like log base 3 squared? What is this equal to? Well, the question is here, what power do I need to raise 3? So the answer will be 3 squared. Well, if we look at this question, what we see is that the power, the exponent has already been given to us. That is equal to 2. So 3 squared is equal to 3 squared. Well, there is no surprise there. But what it means for us is that log base 3 squared is just equal to 2. Now, let's have a look at another example. Log base 10 cubed. What is that equal to? Well, the question again, what power do I need to raise 10? So it will be equal to 10 cubed. Well, 10 cubed is equal to 10 cubed, or 10 to the 3. So log base 10 cubed has to be equal to 3. What happens, for example, if I have log base 5 to the negative 1? Well, again, what power do I need to raise 5? So that answer is 5 to the negative 1. Well, 5 to the negative 1 is equal to 5 to the negative 1. So here, the answer to log base 5 to the negative 1 is just negative 1. Last example, because I always like to show you the ln examples, the natural logarithm examples. Ln e to the 5, what is that equal to? Well, what power do I need to raise e? Remember, ln is always base e. So the answer will be e to the 5. Well, e to the 5 is equal to e to the 5. That's the only power that I can use here. So the answer will be 5. Well, see what's happening in here. In each of these questions, the argument is some power of the base. So in the first is 3. In the second, we have got the argument as the power of 10, which is our base. In the third example, we have got the power of 5, which is our base. And in the last example is e, because remember, ln is base e. So the answer in each of these cases, when the argument is the same as the base, is just the power itself. In the next example is 3, and then it's negative 1. And in the last example is the positive 5. So what happened here is that I could cancel out the log and the base of the exponent, and the answer is just the power, just the exponents itself. Now let us make a little bit more space and discuss the theory behind it. So why this is true for every single base. Because so far I only shown you 5 examples, but I haven't proven you that this is going to work for every single base. So let us again go back to the definition of the log. So log of some base with some argument, that is going to be equal to the power. Because remember, this b, same base, had to be raised to some p power, so that's going to give us the answer or the argument. So log base e is going to be equal to p if and only if b raised to that same p power is equal to that a, that argument. Now, what's special about our case? Special about our case is that this argument is specifically the same base to raise some power. I don't know, I'm just going to use x. I don't want to use p again here, because then I don't want you to get confused with the two different p's. So I'm using a different letter, I'm using x for it. But now, if I look at here, I've got b to the p. Now the argument is equal to b to the x. So it's not a anymore, it's this specific b to the x. So what does that mean to me? Well, it means to me that the power have to be equal to x itself. So, conclusion, logarithm base b to the x have to be equal to x, because x is that specific power that I need to raise b to. So it's going to be equal to b to the x. Now, what does it look like in the case of the ln? So ln e to some power of x is going to be equal to that x. Again, you're probably getting bored of it now, saying over and over again, but ln is always the same as the e base logarithm. So that's why in here, ln e to the x will answer down to x simply. Now again, let us make a bit more space. And now let's talk about the opposite case and discuss when exponents cancel out logs. So what happens if I have got 3 to the log base 3, 2? Well, what is that equal to? Well, let's focus on what's in the exponent. In the exponent, I have got log base 3, 2. Well, that's going to have to be equal to some power. I don't know what, but that's equal to some power. Remember, logs is another way of thinking about powers. Now remember the definition of the log. Log base 3, 2 equals to p if and only if 3 to the p is equal to 2. But now let's compare the first expression and the last expression. What's happening in here? I know that this log in the exponent is equal to that p, but the whole expression 3 to the p is equal to 2. That also means that this whole expression 3 to the log base 3, 2 is just equal to 2. Now let's look at another example because this might take a bit of time to sort of digest. So 10 to the log base 10, 3, what is that equal to? Again, first just concentrate on what's in the power. Well, log base 10, 3 have to be equal to some sort of exponent because that's the definition of the log. But this is only true if 10 to the p power is equal to 3 itself. And again, when comparing the first expression and the last expression, what we notice is that there is exactly the same thing in the power because p is equal to log base 10, 3, but the whole expression is equal to 3. So 10 raised to the log 10, 3 has to be equal to 3 itself. Next example, 5 to the log 5 base 0.25. What does this equal to? Well, again, log base 5 0.25 gonna have to be equal to some power if and only if that same base 5 to raise to this unknown power is equal to 0.25. And just like in the previous examples, look at the last expression and compare it to the first expression. Now we can conclude that 5 raised to the log 5 base 0.25 has to be equal to 0.25 because that specific log has to be equal to that same p power, which in our case is 0.25. Last example before we go into and talk about the generic case without any specific powers is the natural logarithm, because in economics that's a very important base logarithm. So e raised to the ln 5, what is that equal to? Well, again, ln 5 has to be equal to some power if and only if e to the raised to that same p power is equal to 5. And again, e to the p equals to 5. E to the ln 5 then have to be equal to that 5 because look, these are the same expressions. E to the p, because that p is ln 5 of itself by the definition of the logarithm, then the answer to e to the ln 5 is gonna have to be 5. So let us observe what's actually happening in these questions. Well, I've got the same exponent base as the log base, which is in the exponent of that base. So 3 raised to the log base 3, 10 raised to the log base 10, and 5 raised to the log base 5. So in the exponent, I have the same logarithm base as the exponent base itself. And then the exponents and the logs cancel each other out. So the answer is going to be the argument within the log of the exponent. Let us make a bit more space and look at the theory, the generic case. So why is this true for every single base? So again, what we know is log BA is equal to some power if and only if b to that same power is equal to this argument that we talk about here. That logarithm itself is the specific power that I need to raise the b to so I get to the argument. What does it mean for my case? Well, I've got b, I'm going to raise it to log BA. That's going to have to be equal to something. But when I compare this expression with the logarithms definition, I spot that this log B of A is equal to the specific P. So this expression is a fancier way of writing this B to the P, but again, according to the logarithms definition, this log B to the P have to be equal to A. So this whole expression cancels down to A. The practical effect is if you see a number raised to that same base logarithm in the power, then the exponent and the logs cancel themselves out and your answer is just going to be whatever is in the argument. So what does it look like for the ln, for the natural logarithm? So e raised to the ln of some argument is always going to be equal to that argument. Well, I hope I didn't bend your mind too much in this video, and I hope that now you have a better understanding of when and why you can cancel out exponents and logarithms. I hope to see you in the next video when I'm going to list you all the logarithm rules. Thank you for watching. Bye.